Histograms offer a good option to visualize the distribution of a single set of numeric values. The values are first grouped into a defined number of bins, usually of equal width. For example, we could take the numbers 1 through 100 and bin them into 10 equally sized bins. One for values 1 through 10, one for 11 through 20, and so on. In that case, each bin would have exactly 10 values in it, and the heights of the bars in the associated histogram would all be the same. Those heights can represent either the total number of observations in each bin or the proportion of total observations in the dataset the bin accounts for. Let's generate a set of random values we can use to create an example histogram in base R. We'll use a function called rnorm that allows us to sample randomly from a normal distribution. We'll sample 50 times from a distribution with a mean of 0 and standard deviation of 1. And we'll use the assignment operator to assign the 50 values to a new object called rand50. Now, let's say we wanted to see how these values are distributed. Simply running the hist function on our rand50 object gives us an initial histogram. The number of bins created is calculated automatically, but can be changed with the breaks argument. For example, in this case, values were counted into 9 bins. What if we wanted finer resolution, maybe 15 bins? We can rerun the function and set the breaks argument to 15. We can alternatively define the specific breakpoints for the bins with the same breaks argument. For example, setting breaks to -3, -2, -1, 0, 1, 2, 3 gives me this plot. And while it probably isn't something you'd want to do often, the bins don't necessarily have to be equal in size. For example, we could set the breaks to -3, -2, -1.5, 1.5, 2, and 3, which creates one wide bin containing values between -1.5 and 1.5, and narrower bins for everything with an absolute value between 1.5 and 3. Now, if you want to look under the hood a bit more here, this hist function is doing a couple things. Its native behavior is not to generate a plot, but to generate an object of class histogram. This is a special class of object. It's a list, and the items in the list contain the information you'd need to construct a histogram. We can see this if we run the hist function again, but this time add the argument plot equals false. The list that's returned has 6 entries. The first defines the boundaries of the bins, and the second, named counts, stores the counts within each bin. By default, the hist function has the plot argument set to true, causing it to first create this list, and then automatically run a second function, plot.histogram, that takes this list as input and actually creates the plot. We'll move on to the next plot type, scatter plots, in the next video, and revisit additional customization methods that apply more generally to multiple plot types, including histograms, in another video.